Hey astronomers, Newland here. So let's talk about how you're supposed to do this lab that I'm asking you to do. First of all, the three open clusters and the one globular cluster, finding them, sketching them, zooming in, all that kind of stuff, getting this information, pretty straightforward. I really want to talk about the binary stars. So I'm asking you to gather information on two stars that happen to look close together but really aren't, but each one turns out to be its own binary. So this first bullet here, this first one, will actually have two stars for Alcor and two for Mizar. The second one is an actual pair of orbiting stars, Castor A and B, so write them down. The third pair is one that looks like they're orbiting each other, but they're not. So those are called visual binaries, but it's not a literal binary. So write down the information for that. And then there's four of them in Trapezium, which is in the heart of the Orion Nebula. And then we're going to make once we fill out the chart, I'm going to show you about the chart in a minute. I'm asking you to generate an HR diagram and come back here and paste the HR diagram and answer these four questions. So I'm in Stellarium. I'm set for Bel Air. Let's change the time to, instead of 7 p.m., 9. It doesn't have to exactly be 9. That's close enough. I'm going to pause it so it doesn't change on me. I'm going to get rid of the side menu. Okay, that's pretty good. So here's the template, and this is linked in the document. So there's the designation, so the name that you can search for in Stellarium. I've actually filled in the right ascension and declination. That way you can verify when Stellarium is hard to use if you're looking at the exact right spot. And then apparent magnitude you'll write down from Stellarium. Distance you'll write down except for these four, which I'm giving you. The spectral type, which will be a letter and a number like A5 or G0. And then once you have all of the spectral types, the letter and the number, you can come over to this thing and say, oh, an O9 should be 32,000 Kelvin. An A1 should be 9,200 Kelvin. An M1 should be 3,700. So you can use, so that's linked right here. It's also linked back in the lab. So you'll have the spectral types here, you'll have the temperatures here, and once you do, these two columns will auto-magically turn into a bunch of numbers. These are wrong right now. So you got to fill in all the rest of this. These three columns you'll get from Stellarium. This one you'll take the spectral type and look it up in that table. And once all of the numbers are there, these two columns will be nothing but numbers, and I'm going to show you how to make a plot. So let's try Alcor. So Alcor is an interesting one to try to find. So it's in there's the Big Dipper's, pot. There's the handle. We're going to zoom in. Notice that I am set for Bel Air, so I know I'm at least in the right location. And once I zoom in, and you can clearly see there's Alcor, there's Mizar. So this is a visual binary. They're not really next to each other. They just look like they are. And as I zoom in on Alcor, it's actually a real binary. Now, you don't have to actually click on each of them here because for some reason, for this binary, both of the spectral types are listed right there. They're both about the same distance away because they're less than a light year from each other, apparently. There's their apparent magnitude, their right ascension declination, and one of them is A5. That's look at it this way, A5 and M3. O, be a fine gorilla, karate, me. So the M1 has to be not blue and the A1 has to be blue. So this one up here is clearly the A, which is an A5 spectral type, and this is the M3 spectral type, but they're both the same distance and about the same magnitude. So you'll put that in the chart, and that's those two. Now I'm going to zoom back out and find the other two that are associated with this visual binary, Mizar, and you can search for them by name if you want. Mizar. And notice that Mizar is in kind of a weird situation. When I zoom in, the second star in the pair is listed as Zeta Ursae Majoris B. So there's A, there's B. I don't know why they don't have the same name. And here, instead of listing them together, you can click on them independently. So that one is 80.53 light years, and this one was, I think, 81, 85, right? Wow, that's really far apart. Maybe there's just a visual binary. I don't even know. But make sure to put the spectral type for this guy, which is an A 1.5. You can call that A1 or A2. I really don't care. Pick one of the two. And then this one is an A1 as well. Forget the lowercase letters. They don't mean anything. So A1. So that's how you do Alcor. That's how you do Mizar. And let's try Castor. And it's also a double star. And when you zoom in, there's Castor A, there's Castor B. So actually, that's not Castor B, is it? Hang on, y'all. Okay, yeah. Huh. Weird. Oh, that's the same deal with them written together. So Castor A is A1, Castor B is A2. Is these two are also so close together that you can't separate them. They're about the same distance, same magnitude. So unlike Mizar, where you can see the difference between them, these two are a real binary. So A1 for one, A2 for the other. Okay. And then what was the next one? So that was Alcor, that was Mizar, that was Castor that we just looked at. Oh, let's zoom back up here. Oh yeah, and then HD, I'm going to highlight this and copy it. 238107, 238107. And I'm going to zoom out to show you that this is a visual binary, but not a real one. So there's 108, there's 107. So if you click on this one, it tells you its distance is 475 light years, its magnitude, its spectral type is F8. If I click on the 107 one, if I can get it to click, it's a G0, distance is 1,000 light years. So you can see there's a big difference there. So this one's definitely just a visual binary. These stars definitely aren't next to each other. Unlike the Castor one, where they were so close together that Stellarium listed them with a plus. Here it's a visual binary, so it's literally two different stars. Okay, so Alcor A, B, Mizar A, B, Castor A, B, and then the two Henry Draper stars, 107 and 108. Cool. Now, 41 Ori, which is in, and notice all four of them show up. So there's A. So I'm going to kind of zoom in so you can see them all together. And if you can't find them all, you can say Ori, because 41 Ori. B is kind of hard to find. They don't necessarily highlight it. But for each one of these, A, B, C, and D, 41 Ori A, B, C, and D, write down their magnitude, their spectral type, leave off the V. This is a B1. 41 Ori A is a B0. 41 Ori C is an O7. 41 Ori D is a B1 or B2. I don't care what you call it. 41 Ori. Is that all of them actually? And for all four of them, make sure to write down the magnitude, the spectral type, again, just the letter and the number. The right ascension and declination are already in there. And in this case, I had to look up the distance for you. I went to find a paper that referred to it. So you'll fill in the absolute magnitudes from Stellarium, the distances from Stellarium, the spectral types from Stellarium. And then once you have one, so like, hang on, Theta Orionis D, which is 41 Ori D, is a B 1.5. So I would come over to the template, and for this guy, I would write B, let's call it a 1. So now I got to click on this link to open up this thing and go to the B's. B1 is 26,000, copy, paste. And notice that now for 41 Ori D, oh, I left out the absolute magnitude, apparent magnitude. The apparent magnitude is 4.75. So when I type 4.75, so look, once I fill in the absolute magnitude, the distance, the spectral type, look up the temperature, these two columns will be calculated for you. The log of the temperature is 4.4, and the absolute magnitude is negative 1.68, okay? So what do you do with that? So I'm going to zip ahead here, and I'm going to get rid of these, make it a little less easy. And I'm going to highlight the log and absolute mag columns. I've already done them all. Notice they're not quite in the same order. I kind of mess with that, but I highlighted all of that and I'm going to click insert. This is the second part. You filled out all the data. The second thing is to make an HR diagram so you can answer these 4 questions. So once you filled out the template here, let's delete that because this is the actual template I'm editing. I didn't make a copy. So anybody who opened it right now will see the answers. So anyway, there's our list of spectral types and temperature. So I've highlighted, again, I didn't highlight the columns, y'all. I clicked on log T over to abs mag and I highlight down to there. And now I'm going to choose insert and I'm going to choose chart and I'm going to make sure it's scatter, which it is. And log T should be on the x-axis and absolute magnitude reversed should be on the y-axis. And I reversed it because remember that absolute magnitude, as the number gets smaller and more negative, it's actually brighter. So I multiplied all these by -1 so that it works the way you think it does. The higher up you are, the actual brighter it is. But the x-axis you need to change. So I'm going to click on this, and I'm going to click reverse axis order. So I clicked on the x-axis and reversed axis order. So this is literally an HR diagram right now. Now we need to mess with it a little bit, but these stars are bluer and hotter. These stars are redder and cooler. There's even almost looks like a red giant way over here because the main sequence would be this line running just like that. I also think, so a couple things. Let's change the label here. H-R diagram. The labeling on the axis is fine, but I would like to change. I'm going to go to setup, and where it says the x-axis, we're going to choose to add labels. I think it'd be cool to do this, but instead of the log t, instead of those numbers, watch what I'm going to do. So again, what I did is I clicked setup. Once I'm in my little chart, I went down to series, and I clicked add label, and I'm going to click in this little area, and I'm going to choose to select a different data range, and I'm going to select these. And I put the star names over the actual stars. So again, what I did is under setup, under series, I clicked add label, and then instead of letting it be a number, I hit this thing to select it, and I went and selected these and labeled the stars. So now that's pretty good. So then what I would do is I would copy this, and I would come over to my document, and I would paste it. Oops, dang it, that did not copy and paste. Let's try it one more time. Let's right click on it. Right click, and can I not copy and paste easily? Well, I got it. Edit, copy. Sorry, you got to do it in the menu. My bad. Your browser may let you do it actually. And I'm gonna go back to my document, and I'm gonna say edit and paste. Let's see if that worked. Do not paste it linked, or it doesn't really matter, but I'm gonna paste it unlinked. And there it is. And then I'm gonna answer these 4 questions and talk about how awesome Mr. Newland is. I'm actually gonna delete it because this is literally the lab I'm editing. So there you go. Hopefully that process will work for you. I told you how to find the stars and how to differentiate which ones are real binaries and visual binaries, where to find the spectral type, how to fill out the absolute apparent magnitude, the distances, the spectral type, how to convert the spectral type to a temperature, and then once you have all your data in there, how to highlight these 2 sets of columns, insert a chart, correct the display so that the X is labeled backward. Reversed order, how to add a label so they're on top of your thing. So that's pretty good. I feel pretty happy about that. All right. Hopefully that will clean it all up for you. All right, good luck.